So in this video, we're going to calculate our confidence intervals, but this time we're going to use the calculator. All right, so I'll recap this at the end of this video, but basically there are three confidence intervals that we're going to calculate in this. And we've done these in previous videos, just want to bring it all together in this video. The first confidence interval we'll calculate via the calculator is the confidence interval for the population mean when the standard deviation is known. Okay, when the standard deviation is known, you're going to calculate something that's called a z interval. And I'll show you where that's located in the calculator in just a second. And the z interval is what we did in previous videos. It's your x bar plus and minus your margin of error. All right, so how do you get to your z interval? You hit your stat button. And then it depends on what type of problem you're working with. Before you even calculate the confidence interval, if your data set, if you're given the actual data values or the data points, your first step is to input that information into the calculator. And you do that by stat and edit. If instead they give you the summary statistics, as I like to call them, meaning they say you have a sample size of 50, the sample mean is this, and the population standard deviation is this, then you're going to use the stats option underneath the z interval. But anyways, um, once you figure out what you have, you go to stat, and then you go to the test menu, and then you're going to scroll down until you see z interval. So let me show you what that looks like on my calculator. I hit my stat button. I right arrow twice to test, and number 7 is the z interval. I'm just going to hit the number 7. And then just really quickly, IMPT input, that's what I was telling you about. So if you have instead the data points, what you're going to do is you're going to select data. And what this means is actually before you get to this screen, you need to go and you need to put your data set into L1. If instead you know the summary statistics, you're going to move over and your input would be stats. What type of stats do you need? You need to know the population standard deviation. That's why it's a z interval. You need to know x bar, which is your sample mean. N is your sample size. And C level is your confidence level. And that's what this slide is just telling you. It's just explaining the different parts of it. All right, let's do a quick example here. The distances traveled one way to work by employees in a company are noted to the nearest mile. These data follow the normal distribution. A sample of 10 employees is chosen at random, and those employees' commute distances have a sample mean of 19 minutes. Construct a 95% confidence interval for the true population mean where the population standard deviation is 4.2 minutes. The key here is that we know the population standard deviation. We know sigma is equal to 4.2. Because of that, we are going to use the z interval option. All right. Other things we need to know. We need to know the sample mean. Okay, because we don't have all 10 of the data values, but they tell us the sample mean was 19 minutes. We need to know a sample size. We have a sample of 10 employees. And our confidence level. Our confidence level is 95%, so 0.95. So we're going to put all that information into the calculator. Here we go. Okay. So stat, I'm going to go to test. And number 7, Z interval. So either you can scroll down there, you can hit the number 7. This time we have the summary statistics. Okay, so what was our standard deviation? It was 4.2. X bar was 19. The sample size was 10. And I believe we had a 95% confidence level. Let me double check that. Yeah, everything looks good, 0.95. Go to calculate. And there she blows. That is your confidence interval. So our confidence interval goes from 16.397 up to 21.603. And same interpretation as we talked about in previous videos. We are 95% confident that the true population mean is somewhere between 16.397 and 21.603. Okay, so in that previous example, we knew the population standard deviation. Well, now what if we do not know the population standard deviation? Then we're going to use the t-distribution, as we discussed in previous videos. This is where we're going to now calculate what's called a t-interval. So I can't stress this enough. If you know the population standard deviation, it's the z-interval. If you do not know the population standard deviation, you have to use the t-interval. All right, they're just giving you some properties of t-intervals, which I've discussed in the previous video on population mean confidence intervals when you do not know the population standard deviation. All right, the t-interval is located right underneath the z-interval. It's number 8 for most of you guys in your calculator. And once again, it has the same kind of options for your input. Either you put in the data or you have stats. Data means you have a list of the data points and you put those into L1 before proceeding. If not, you have stats like we had in the previous example. All right, consider this example. A group of 10 men were subjected to a stressful situation in a controlled experiment, and their heart rates and beats per minute were recorded. The data from the experiment are given below, assuming that the data are normally distributed. A little sidebar. The reason why they keep on saying assume the data is normally distributed because I didn't talk about this before, but we can really only do confidence intervals in one of two situations. Either the population has to be normally distributed, or the requirements of the central limit theorem for sample means has to be satisfied. But either way, we'll be good. Find the 95% confidence interval for the mean heart rate rounding to 2 decimal places. Alright, so in this case, what we have are the data values. These are the data values, okay? So we know it's a confidence interval for the population mean, and the difference between Z and T is, the question is, do you know the population standard deviation? Do they tell you sigma is this? They do not. So for this example, we have to do a T interval. Alright? In order to do a T interval, well, since we have the data set, we have to input this data set into L1. So let me see how I can do that. So clear. So remember to enter our data, we hit stat, we hit edit, number 1, and L1 is our list there. Let's grab some of these, 124, 122, 125. Okay, what are the next three? Let's see. 129, 125, 126. Okay, and the last few, 123, 130, 128. But the last one was 122, okay? So we have a total of 10 data values here. Always wise to go back and double check you input them correctly. Now that I have my data set in L1 and I realize I do not have a population standard deviation, we go to stat. Now we go to test. And we're going to, let me scroll down here. We're going to go to right there, number 8, T interval. T interval. Because we do not know the population standard deviation. However, this go around, we don't know the stats, but we have the data. Okay. Under list, you're going to type in the name of the list where you input all that data. Our list was L1. In case you have something else in there, if you remember how to type in L1, it's second 1 is how you type in L1. Frequency, leave it at 1. You won't change that. And what is our confidence level? They told us to calculate a 95% confidence interval. So 95 is our confidence level. We go to enter, we calculate, and there we go. 123.37 up to 123.43. So we are 95% confident that the population mean heart rate and beats per minute for all men in the stressful situation is somewhere between 123.37 and 123.43. All right, and they're just giving you more information on, oh, that's the actual answer right there. So you can see that, yes, we got the correct answer. And lastly, how do we find confidence intervals for the population proportion in the calculator? So in the previous video, I showed you how to do it by hand. If you remember, this is how we do it. But let me show you how to do it in the calculator. To do it in the calculator, when you want to find a confidence interval for a proportion, it's called a one prop z interval is what it's called. One prop z int is the confidence interval for a proportion. The one stands for one sample, don't worry about that, but prop is short for proportion. And when it comes to the information you need for a confidence interval population proportion, all you need are three things. X is your number of successes. N is your sample size. Okay. And then, of course, C level is your confidence level. All right. And both X and N have to be whole numbers. Just in case you come across a situation where you're working with decimals, make sure X and N are whole numbers. All right, here we go. In a random sample of machine parts, 20 out of 235 were damaged in shipment. They want us to create a 98% confidence interval to estimate the proportion of damaged machine parts in shipment. Okay. So right off the bat, we know that if it's a confidence interval for population proportion, it's going to be a one prop z interval. We need an x and an n. Our x is 20, our n is 235, and our c level is 0.98 because they want a 98% confidence interval. Stat, go to test. We're going to scroll down a bit. Where are you at, mister? Looking for one prop z int. There we go. For me, it's letter A. Yours may be slightly off, but one prop z int. There we go. X is 20. N was 235. C level is 0.98 this time. We calculate, and there she blows. 0.04276 up to a 0.12745. And thus we are 98% confident that the population proportion of all machine parts damaged in that shipment is somewhere between those two proportions. Alright, so to wrap this video up, what we what we did in this video is we used the calculator to calculate confidence intervals. And it boils down to this. You use a Z interval. Z interval is used whenever you're trying to calculate a confidence interval for a population mean. A confidence interval for the population mean when the population standard deviation is known. This pen. Population standard deviation is known. Okay? You're going to use a T interval You're going to use a t-interval when it's a confidence interval for a population mean. But this time, the population standard deviation is unknown. Very important distinction there. Okay, let's just come down here. Population STD unknown. Okay? And then lastly, you're going to use a one prop Z interval when you're trying to calculate a confidence interval for a population proportion. For a population proportion. So that's really what this section breaks down to. You have to understand what scenario you're in, and then based off the scenario in, that's the correct confidence interval that you need to use. All right, see you all in the next video.